So let's jump to the results. And here we show that if you the horizontal axis is the percentage of cities being locked down, so completely locked down. Now let's not think about restricting some between 0 to 1. We just lock down to phi ij equals 0. And if that's the case, if we want to only have the maximum number of cumulative number of infections as we have today for China is around 80,000 some infections all over China until today, then we only need to lock down about 5% of cities. If we city pairs, we do not need to lock down all over China. So this is just to give an intuition that when you are doing the route-specific restrictions of travel, you do not need to lock down the whole country. Only 5% of the links between cities need to be locked down. And here, we further make the model flexible to allow not only lockdown, but some restrictions between 100% to 0%. So each city can select the percentage of travel they can reduce. And here shows from the social planner point of view, if you think you are president of China, premier of China, so you can think about the top list of cities from our social planner problem that needed to be restricted as an outbound city. So first, not surprisingly, is Wuhan. And Wuhan, we have different parameters to show the range of the estimates. But in every case, you see that the horizontal axis is the size of the restrictions, the intensity of the restrictions. So here shows that the restriction of the intensity of travel is approaching 1. That means in an optimal world, when the government decision maker consider about overall reduction of infection and overall economy loss, they need to almost lock down Wuhan. And those are the cities also high ranked. And if you look at those cities, very interestingly, they are all, the top 10 are all from Hubei province. So that means this is very similar to what already or actually being done in China when China locked down Wuhan. And consequently, the travel between Wuhan and outside city are all suspended. And further, after a few days, they locked down Xiaogan, Huanggang, Hezhou, and Jingzhou, and many other Hubei province cities. And after a few days, the whole Hubei province locked down. And this is consistent with our model because our model, one important term, as I showed, shows that the centrality of the epicenter or the city near the epicenter is critical to be restricted in order to have the optimal restrictions. But interestingly, we also see some other cities outside the Hubei province that need to be prioritized to be restricted, like Wenzhou, like other Chongqing, other cities. And this is from the perspective of which cities we need to ban or restrict the travel to some extent from outward transportation. Let's now think about from cities who need to think about which cities they need to restrict the travel from. So from Wuhan, and here is another list. Here, the top one is Guangzhou. So as a mayor of Guangzhou, they need to think about Wuhan. They need to first restrict the travel from Wuhan. And also the Shenzhen decision maker also need to think about banning or restricting here because this is pretty much approaching 1. All those cities need to immediately think about prioritizing travel ban or restrictions from Wuhan. Those are the top list of cities which need to restrict the intensity of outbound restriction from Wuhan. And very interestingly here, if you look at Beijing, so from the outbound restriction point of view, Beijing is a city we need to restrict the outbound. But there are 2 scenarios. One is the function we call the coordination social planner. So if all the cities can coordinate with each other, compared to without coordination, you will see that in each parameter, you will see that the restrictions of coordination is smaller than non-restriction. That's very interesting result. That means when all the cities acting together, there will be spillover effect. So the cities may not be acting as stringent as they did independently. So the spillover effect will reduce some of the travel restrictions for some cities, which will reduce the economic cost and other costs to those cities. So the coordination may not be a bad thing. It doesn't mean that some city may act first and hurt their own economy. Sometimes that means smaller restrictions can be implemented to achieve the same goal. And these are the two. And here show exactly if you are a policymaker in China, there are we know that there are two different worlds. One is without any travel restrictions. What's the population flow between cities, between pair of cities? But from our model of social planner and coordinated social planner problem, we also know that what's the optimal travel flow between cities. So the difference between these two will be showing us which set of cities need to strengthen the regulation, the travel regulation, and some small specific cities may need to may have some room to lose their restrictions on the travel. So here are this map shows the cities that have with negative difference. That means the optimal difference, optimal travel restrictions is smaller than what they already actually did in restricting travel. So then this arrow point to the city of destination cities and origin cities. Those are the pair of cities, the top 50 routes in China. Definitely, there are 360 to the power of 2 pairs. But those are 50 routes can be, the regulations of travel can be loosened. And in comparison, there are 50 top cities need to strengthen their travel restrictions because their optimal travel restrictions impose even stronger travel than what they already or actually are doing. So here, especially if you look at some cities in Guangdong province, Guangzhou, Shenzhen, those are the cities really needed to strengthen their restrictions in order to match their optimal travel restrictions according to the coordinated social planner problem.